We've both worked with these microservice system, distributed system things, and it's a bugger, not to put it mildly, mind my French. As a developer, you feel like everything's moving around you, and you just want to concentrate on the one service that you're trying to develop. Like, how can you meet that expectation without going completely insane? So this presentation is it's a collection of thoughts that we put together over the course of the last 12 months or so about some different ways in which you can lessen the pain. Okay, so we'll have some pain, but we can make it feel a little bit better. We can do some palliative care at least, anyway. You both know who we are, right? I'm Dave.
I'm Spencer.
I live in London.
I live in Utah.
I work for Pivotal.
Oh, yeah, so do I. Go figure.
First step is admitting you have a problem.
Yes.
No, that's not a problem, seriously. If anybody wants to come and join us, stick your hand up, come and see us afterwards. Okay, so we've got some slides, right? Yeah, should we have a look?
That's us, yeah.
That's us. I like this picture. This is from, what's his name? Little Idea.
Andrew Schaefer?
Andrew Schaefer, I think, yeah. And it's actually, this is a track in Spring 1 called the Cloud Native track, and you've seen Cloud Native, plastered all over the place anywhere. Does anybody not know what we mean by Cloud Native? I'm sure there are, everybody's heard it now. Okay, good, well done, thank you.
Yes, thank you for admitting that you don't know what the buzzword means.
We didn't just invent it. We picked up a meme, I think, but we've run with it quite a long way, especially Andrew. So he made this picture, and it sort of shows you how all of the pivotal stacks that we use every day fits in with the cloud native philosophy, if you like, because it's sort of a movement or a state of mind more than actually a tool that you can go out and use. And I think, I don't know, I could paraphrase what I think is important about cloud native. It's what my experience was like when I was working in a big distributed system. As soon as you make the rule, right, I didn't make this up, but as soon as you have this rule, if you write the code, you own it, you pretty soon learn what cloud native means. Agree?
Yes, I do.
So as soon as you own it, like say maybe you run it, or maybe you just own it to the extent that somebody else runs it, but if it goes wrong, it's you they're going to call. And that's a wake-up. That's a lesson, right? And everybody learns it quite fast when they're on the end of a telephone at 2 in the morning or whatever it is, which never happened to me, actually, because we started building stuff as soon as we started building anything that was going to fit into a distributed system. We started following these rules, whether we knew it or not. I don't think they'd been codified at that point. But there's this thing called 12-factor. Anybody heard of 12-factor apps? Yeah, quite a few. What's the website? 12factor.net.
12factor.net, yep.
Yeah. So
Heroku's manifest on best practices that they saw as they were building out their systems.
Yeah. And what it comes down to really is, making it easy to, well, there's a couple of things, isn't it? It's introspecting, but so that you can tell what's going on, right, in a running app. But it's also, from the developer's point of view, it's, you build the code once, and then you can ship it anywhere.
Yeah.
And it's always the same tarball, basically.
Yep, a way of packaging and designing your applications such that the configuration can come from an external place. It's a single process, it's simple. It listens, you export a port that it listens on. That's right. A bunch of different things that allow an application to be moved from environment to environment and to be able to reason about it in a simple way without having to come up with all the rules on your own.
Right. And actually, that's a discipline, but it's a good one because it keeps you honest, right? It keeps you on the true path. And so how do we help? Well, the first thing we do is Spring Boot, right? And we've all heard about Spring Boot. Makes it really easy to write 12-factor apps. That's one of its main goals. I mean, we never phrased it in that way when we sat down and wrote it, but essentially that's what we're doing. So you've got Spring and Spring Boot, Spring Cloud sitting at the top of this stack, making it easy to write the code. And then you're deploying that into some kind of cloud-native runtime. What's that? That's something where it's easy to take those, binary bits, and you just sling it in, and it knows what to do with it. That's a platform.
Yep.
Right? So we've got one of those. It's called Cloud Foundry. There are others that you might come across. We also have one called Lattice, which we've probably mentioned somewhere in this presentation. I'm not sure we'll demo it.
Yeah, if you didn't go to Matt Stein's presentation earlier this morning, catch it on the videos.
Yeah, it's probably a good idea.
Yeah.
Assuming it worked.
It did. It did.
Great. Okay, and then there's a bottom layer here as well, which is sort of more infrastructure orientated. So as a developer, I really don't care about that bottom layer, but it's very important, right? If you're going to implement this thing, to have all three layers. So I just thought I'd bring that up just to give us a talking point, basically, about why Spring Boot helps. And it's basically because it helps you to build these binary things that you can just ship around and run, and everybody knows how to run them because they're very simple.
And I like the layers that create these nice abstractions. Another thing I like about this slide is we didn't call it microservices. I like the cloud native term better than that, partially because micro implies
Small.
Something to do with size, and just in speaking with customers, they sometimes get overworked about that micro, and it's really about what context you're in. But cloud native describes it a little better, and we try and take some of the things with Spring Cloud and eliminate some of the boilerplate that comes with these distributed systems. So.
Okay, so what are we actually going to talk about? The developer experience, right? What's it like as a developer? In the trenches, right? So that whole slide above, that was really about, I didn't use the word microservices until now, but that's what it's about, right? It's about an open, flexible architecture, which has benefits, right, in terms of time to market, the huge business value there. But, like I said at the beginning, the developer, poor little developer, he needs to be able to work on one thing at a time, otherwise it's pointless, right? There's no point having to build the whole universe every time I make a change to a line of code.
And I have coworkers, former coworkers here, where we had to do that. We had to rebuild the universe, and dozens of services to see that our change worked.
So what tools and techniques are around? What can we do to help with that a little bit?
And of course, how can the code that we wrote and released at last year's Spring 1 and Spring Cloud help? How can Spring and how can Cloud Foundry help us overcome lots of the little nuances that can tend to drive you crazy when you're trying to build these applications?
Yeah. Okay. Right. So this is really the driver for everything. If you write a line of code, then this is the last kind of sociological slide. The rest of it is all technical and hopefully some demos. But this is the sort of organizational structure one, the Conways Law slide, basically. If you can get this mentality in your organization, if you can get to the point where if you build some code, if you write some code, build it, then you run it or own it, and the rest of the organization recognizes that and accepts it, then you're there, basically. And you'll know when you need to get there. You don't necessarily want to do that for everything straight away, but you probably want to be heading there. What can you do? Okay, so 12-factor principles. Some of the 12-factor principles include things like logs are very important. Log everything. Collect data even when you don't think you're going to need it, because you will. eventually, all right? So here's somewhere where Spring Boot helps, right? So actually, we didn't used to do this by default, but by default now, I think since 1.2 Spring Boot, standard out is the only place where you get logs unless you do something. Like you have to elect some other way of doing it. And standard out is just a sensible way to do it because the operating system knows how to, help you with that. And the platform that sits on top of the operating system, like the Cloud Foundry, does something special with standard out, right? If it's a file in some random location that nobody knows about except you, that's a snowflake, right? Nobody's ever going to know where your logs are if you put them in a file. If you put them in standard out, everybody knows where to find it. That's the principle. And so Spring Boot makes that really very easy because it's the default. It's opinionated in that way. And it also has this thing called an actuator, which is a set of, for want of a better word, non-functional features. And we're going to talk a little bit about those in a minute as a tool. But so there are these endpoints like tracing requests. Okay, so if I want to see, I found this really very, very helpful when I was working with a system in production. If something's going wrong, first thing you want to do is find out, what's the state of the system. You want to get a thread dump, and you want to get, the last 100 requests or something and see what actually happened. Like, what were they trying to do before it went wrong? And that was always very valuable. And then when you've seen that and you say, oh, it didn't work. Why didn't it work? Well, something's obviously not quite right. So what's been configured wrong? So let's go and look at the environment endpoint /env, or let's go and look at the mappings and see if actually the endpoint that we're trying to hit is even there. So this is the reason we provide these endpoints, is so that you can essentially in production find out things that are going to be very important if anything goes wrong. But at the same time, because they're so useful there, they also turn out to be useful at development time, right?
And I find that, and I'm sure if you've interacted with me on GitHub or
right.
Stack Overflow, I've asked you, what does the /env look like? What does the auto-config report look like, right? Maybe you're missing something in your class path. Maybe, it's on the class path, but something else is missing, and so it didn't auto-configure like we thought it would, and so we can see why something wasn't working. That's generally what I ask.
Yeah, we're doing remote support a lot of the time, I suppose, aren't we? So it's good for support, it's good for development time if something goes wrong to find out, how you can fix it. And it's good, when something lands in production, if the worst happens and you have to find out what's actually the state of the system, the data can be there. Okay, on an individual service basis. So we'll talk about the bigger picture later. Yeah, so it's not always going to be a sunny day, is it? You write this code, you get it working locally, you probably write some tests, ship it, right? Send it to the system. Is it going to work? Well, you cross your fingers. If it doesn't, how are you going to find out? So here's a few ideas. So logs, you can definitely go and look at your logs if you're in a platform. CF logs, for instance, will get the Cloud Foundry logs. And actually, this is the thing that I find quite useful. Changing the log levels at runtime. Everybody since like the year dot has asked us about that. How do I do that with my Spring app? And only actually pretty recently, this time last year, we demonstrated it right on in the Spring Cloud stack. So we do that, just with a simple environment variable change. Well, environment variable, not the operating system, but the Spring environment logging level. So that's actually a good trick to learn. And that's actually through the /env endpoint. We post to that logging.level.org.springframework.security equals debug is my favorite. Because I always want to know why I can't log in. Other useful endpoints we just talked about. Another thing that people do is they put in feature switches, right? So you put in stuff in your app that isn't normally active, so code paths that you can activate by, again, changing the environment variables at runtime.
Yeah, it's a pretty common thing to do across, especially when you're introducing, something new and you want to say, hey, some subset of users do A/B testing on this feature or something like that. Pretty common thing to happen. Remote debugging is important. I don't know how many times I've had them turn on remote debugging so I can connect to some server to check it. We'll also see, well, maybe talk about some neat tools that some people on the Spring team have been working on.
Yeah, we'll see that later. I think for me, remote debugging is a last resort. I only ever do it if I really can't find another way, because it's painfully slow usually, right?
Yes, it can be very slow.
Experience. So, but if there's an app that just won't behave, then sometimes putting a breakpoint in is the only way to do it. What I hope to be able to show you, maybe it'll have to be after this presentation because we've had an AV issue and I can't actually connect my laptop, which we'll get slides later on and I'll explain what it's all about, was this idea that you could also deploy locally. So deploying locally is the nirvana, right? That's what you really want to do to diagnose a problem. The only problem with deploying locally is my laptop is not necessarily connected to anything else. So the trick is going to be how do you get a local deployment of a service I'm working on talking to and interacting with a bigger system, one that somebody's deployed in an integration environment probably. And we'll show you some stuff to do that later on.
So this is just a simple diagram that we used last year, explaining some of the key components of Spring Cloud, the config server, which allows each instance to get configuration from a centralized location that allows you to version configuration and provide this configuration to each instance individually rather than having to package it up with the application. The load balancer you see is a client-side load balancer that interacts with the service discovery mechanism to get a list of available servers that it can talk to. Anything else you want to say about this one?
No, I'm fine with that.
All right. So I want to talk a little bit about some of the common abstractions in Spring Cloud that we will use to do some of these techniques. There's a discovery client. That API allows a service to register, and then it also allows services to say, hey, I need an instance of service X or Y, and it will bring back a host and port combination, a URL basically, to a service that allows you to interact with that, or a list of services. And load balancer is an abstraction over Netflix Ribbon, which allows you to plug in an algorithm to decide which of these X instances should I use. It can be round robin, it can be random, it could be weighted response time, it can be your own implementation. And of course, the annotation to turn this on, actually that's not the right annotation. That's funny. Okay, should be enabled discovery client.
Yeah.
So we have Spring Cloud Netflix, which uses Eureka for the service discovery and registration. And of course, Ribbon is the client-side load balancer. I'm going to go over, I actually have a talk Thursday afternoon, I think the same time, that will go over some of these other implementations of service discovery and configuration, like Console from HashiCorp, the same guys that do Vagrant. If you're familiar with Vagrant, pretty much everybody is. Apache Zookeeper is a pretty common infrastructure component that people from Netflix all the way to, they use for coordination and in distributed systems. We also have implementations of the discovery client for Cloud Foundry and Lattice that use their APIs to for service discovery rather than having some other central service running. Right?
Yeah, so I think the next slide is the important one probably because it's actually, we're going to talk about each one first, right? So before we do that, okay. So let's just distinguish quickly on the previous slide, just distinguish carefully between discovery and load balancing, because it's actually the load balancing that we're going to use in a little bit to kind of peel open what's going on inside a remote service and try to manipulate it so that it'll help us to diagnose a problem locally if we're doing some local development. Okay, so then we're going to talk about different kinds of discovery. So the Cloud Foundry one is kind of interesting because it's read-only, right? You can discover all the other services, but the registration is done for you. You don't actually have a writable registry.
Yeah,
so that has some interesting features.
When you CF push, that's where registration happens, and then a discovery client would use the Cloud Controller API to find instances that have already been registered with Cloud Foundry.
Which then, of course, can only tell you a single address for a scaled-up app. So that's the limitation of that, but that's not the only way to do things in Cloud Foundry these days.
Yeah, there's an option to do direct.
And then you'd need
host and port routing.
Need a Eureka in that case, or a Zookeeper, or a.
Yep. Which Scott was showing us last night in the keynote, right? And Lattice, when Lattice came onto the scene, I was talking with one of the other Spring developers last night, and how they were surprised how quickly we came up with a discovery for Lattice, just because the API was actually so very simple to use. But again, it's read-only. When you do a Lattice LTC create, right? That's when registration occurs, and we use one of the APIs from one of the Cloud Foundry components called Diego. Some interesting things both about Lattice and Cloud Foundry. They add some profiles by default to your Spring application so that certain auto configuration can happen for that particular discovery client. And we have a few connectors that allow you to connect to some basic services, database, messaging.
So yeah, I just want to go back to that profile thing. So think about what that means for a bit. So remember, we've got this binary tarball thing that we want to just move around through environments. What this is telling me is something quite interesting, right? So I can take the same, because I've written the app in that way, I can take the same binary distribution, I can run the app in Cloud Foundry, maybe that's the production target, but I could have a little integration environment using Lattice. It's much simpler to set up, maybe a little bit easier to manage and interact with. The same tarball is going to run there, but it will behave slightly differently, and the slight differences are all driven by this Spring profile feature, right? So you can pretty safely write the same code at enable discovery client, right?
Yep.
That's why we have this abstraction in your Spring Cloud application. Just ship it and run it in a number of different environments, and it should work in all of them, and that actually is quite valuable to be able to, to control and to probe it at development time and integration time.
So as we mentioned before, you saw Eureka running on Cloud Foundry in production. I believe Matt showed, he has a pretty cool demo of, he calls it Catalyst. It's a Lattice application that you can download, and then with a click of a button, you can deploy config server, you can deploy Eureka onto Lattice if you want the more fully featured service discovery on that particular platform. And we saw the managed version of Spring Cloud Services in the demo last night. We'll see a little more tonight.
Yeah, so there's that commercial Eureka instance, like the minute is what it is, how it's implemented using Spring Cloud Eureka. So that was in the demo last night. That's now a native service in Cloud Foundry. So for a developer, you don't have to write any apps to get Eureka working. So that's nice. But it's sort of interesting as well in a different way as well, because like I just said that the Lattice and Cloud Foundry service discovery are read-only. So that's a little bit of a problem in some ways, right? And so actually what I'd like sometimes is a combination of the two. I don't mind using the native Cloud Foundry discovery if that's appropriate, maybe in production that's all I need. But at development time, how about having a writable registry at the same time so that I can dynamically register something that I'm building myself and I want to test?
Yeah, the advantage that you gain there is that you could register something outside of Lattice or Cloud Foundry as an instance of a particular service because you can write to it, and then the services in that cluster know about something outside their own environment, and I think that's the advantage that Eureka gives you there.
There's another layer of that as well, which is the commercial PCF version of Eureka is very secure because we want enterprises to use it. But that means that it's not very easy to register an arbitrary, random, locally running application. It isn't going to have the security credentials to register with a remote Eureka. So why that's interesting is because actually I can bridge that as a developer. If I can push a Eureka server app, bind it to the PCF Eureka that we were using last night, and then they become peers. So they actually share a service registry, and I can interact with in a sort of read-only way with the secure Eureka through a sidecar, essentially, one I've added as a peer. That's a little trick that I've been playing around with, and I was hoping to demo today, but I'm not going to be able to because of the AV problems. And there's some tooling in STS also, which helps you out with that a lot. I'll show you some pictures of that later. There's going to be a diagram that shows how that all fits together, so it'll be quite an eye-opener when you see it happening. Okay, that's actually what I was talking about, isn't it? More or less. So let's say you want to, you have this integration system, right? That's the Cloud Foundry box on the right-hand side. I've deployed all my services up there. The whole system's running there. I don't care how it got there. We'll talk about that later. So there's a service registry as part of that platform. Maybe it's native. Maybe it's an app that I just deployed, like I was just talking about. And then there's a remote, I'm calling it a remote client. That's actually an app, right? That's a service which wants to contact, let's call it red and green, right? So green service on the right wants to contact the red service on the left. Now the red one is the one that I'm working on as a developer. So I just cut some code. I wrote some unit tests. Everything's fine. Now I want to integrate it. Well, how can I do that without slowing everything down and making it, sending it all the bytes across the internet and waiting for them to start up? And how can I do that? So the idea with this is...
And because it's a local change, potentially breaking the other people that are trying to use the same integration environment, right?
Yeah. So the key to this is the green thing on the right-hand side, the green client, because it's using this service discovery client-side load balancing pattern. He actually doesn't really care where he sends his requests, right? He's just going to ask the service registry for a red instance, and the red instance might be local to him, or it might be somewhere else. It might be in a different data center, or it might be on my laptop, and that's actually the picture we're drawing here. So to make this work, you need to have two-way communication, probably HTTP or tunneling and other kinds of protocol. HTTP is easy because tunnels are easy to come by, and actually the STS features, the Spring tool suite features that we just built and just came out, I was showing you last night in the keynote, have a sort of one-click service for this. So I can right-click on a local application, and I can say, run this app locally, but register it remotely, and build me a tunnel back, so that the remote services can contact me. That's really a nice developer experience because now I can set real breakpoints. I'm running the code locally really fast. I can set really fast breakpoints, and if the green service sends a request to my red service, then I'm going to see it stop. And that's actually a really interesting and powerful methodology for developing local applications. But the key thing is it relies on the client-side load balancing. And that's what we're going to talk about next, I think.
So there are a number of different ways that we could achieve so in the case that, let's come back here, there may be some other red deployed somewhere else, right? Some other red service. And how does the remote client, when you make the request, know to go back to the one you want it to go back to, not to the other one that is on some other machine that you don't have access to, right? So there are a number of ways we can do that. We can set a flag in the remote system that says, hey, use this local route. We can determine what looks local, right? Maybe the URL has some pattern in it that we can use to switch off of.
Or another header, maybe the host header, or
right. Yeah. Where did this request come from? And if it came from, my laptop, then we can route it back to me.
Remote IP.
Yeah. Exactly. With a header, with a request parameter, something like that some piece of data that we can use so that the intelligent router, the intelligent load balancer can say, I actually want to go back to this guy.
And it's the 0th bullet point, actually. The default would just be to wait for the load balancer to come to me, which happens often enough anyway, right? I mean, if I'm, developing, in a relatively isolated system, and I'm not going to tread on too many people's toes, I'll just do that.
Yeah, eventually the round robin or random load balancing will hit yours, right? Yeah, I guess that could be that's the default.
That's the default, and it actually works pretty well most of the time in my experience.
So being able to, Ribbon is this load balancer that clients can use to gain some of these features. We've talked about these different load balancing algorithms. One of the other abstractions in Ribbon is a server list. This says, where do I get my list of servers to choose from? The default one in Ribbon is just a static list in a property, right? Comma separated list of URLs.
Which you could change at runtime.
Yep. Yeah. Yes, with Spring Cloud, you could poke the environment and you could change that list if one of these other server lists isn't isn't enabled. Eureka has a fabulously named. I thought Spring was the only one that had bad class names. Discovery enabled, and I don't even know what
server list.
Yeah, news server list.
It would have been even worse if they hadn't abbreviated it. Right?
Yeah. Console server lists, Zookeeper server lists, etc. There are also a concept of filters. What this allows is to, based on some piece of information from the environment, only return a subset of the servers back that were gathered from the list. For example, Netflix likes to try and choose a server from the same zone, right? They try and narrow the list to servers that are actually closer in proximity to the client, if possible. So
what we're interested in is basically manipulating that to send our traffic to the red service on the right, on the left, right?
Yes.
Yeah.
Correct. So we've introduced with Ribbon, by default, it uses properties to change these implementations. It has some limitations in that it creates those instances for you, but we need a little more control. So Dave actually came up with this method of using annotations to allow us to change the Ribbon configuration per Ribbon client. And when I say client, I mean a Ribbon client for the red service, for example. There's a question over here.
I have two questions. One, do you see the Eureka server being, having more instances of the Eureka server running from a discovery service perspective? And have you also seen customers use an external load balancer in addition to
Okay, two questions. These are two questions about what we see in the field, basically, right? You're asking about what we've seen, kind of people using, the way we see people using these things. Yeah, so have we seen people using Eureka peers?
We have.
Absolutely, yeah. I mean, that's actually the way it's built to be used. And the other question was, God, I've forgotten.
A front-end load balancer.
Do people use,
So, for example, Cloud Foundry
big
has its
load
own
balancers.
load balancer in front, right? And for external requests that come in, it goes through that load balancer, and then depending on how you've configured Cloud Foundry, you can either go back through that router to get to other services or go directly to the individual services.
But proxies and front-end load balancers aren't replaced by the client-side ones. It's
Yeah.
just client-side ones give you some, algorithms to play with. You can actually control the process in a bit more of a rational way, right? You're not just one size fits all. You can actually adjust it according to your needs per client. That's what Spencer was just talking about. So a client in this case is actually, I think of it as kind of upside down, right? It's really which service do I want to talk to?
Right.
So if I want to talk to the red service, I need a ribbon client called red.
Yep, exactly. One of the places that we have used this customization, Spring Boot has some fantastic integration test capabilities, right? It spins up your actual Spring Boot service, and you can write tests that do real HTTP communication with your real service. It's really useful. We use it in Spring Cloud to test various features. And one of the things we do, if you can see here, you can see some of the things that I was talking about. So here is the ribbon client annotation. I want it to be for contacting the service called local app, and the configuration for that client is coming from this class. And so down here you can see it's just a basic Spring Java configuration class. This value here comes from the Spring Boot integration test facilities. It says, you can see up here, I started my integration test on a random port so that you don't conflict with anything. So I don't know at startup time what port the HTTP server is going to be running on. So I get that at runtime. And then here you can see this is a simple server list implementation. I don't know if you've actually seen that one. I created a new class called Static Server List. Just given a list, this server object is it's a Netflix object, but says, hey, just the only servers that are ever going to come back from the server list is localhost with this dynamic port. And it allows you to test clients that use Ribbon in integration tests. It's been very useful for us. We use it all the time. Yeah.
Without having a complete distributed system, right? This is completely local to this integration test. I'm going to run within the same JVM. I'm going to run a service with HTTP endpoints. And any client which is inside that, which needs to talk to a remote endpoint, is always going to go to the same place. It's actually just local here, but you could imagine that you could go to a remote endpoint as well, just by configuring it that way.
Yep.
So we're manipulating the client-side load balancer for fun and profit, but to make our lives easier at development time, basically. You had a demo.
I had a demo for this.
Yeah, why don't you do that?
Woohoo, code.
Since we actually have your laptop working.
Let's see. We want to see this guy.
Bigger font.
Yeah, I can do that fairly easily. Let me see. So this is a fairly simple Spring Boot app. You can see I created this with the start.spring.io, right, the Spring initializer. So I have the Eureka client. I also have the ribbon starter, web, obviously, actuator, and a few others that I will show you why they're important here in a second. Two basic endpoints. Since I'm just going to be a client of myself, I didn't want to write two apps. I was lazy and wrote one. So I'm going to be a client to the same app is going to just call itself. So /home here is just going to call me. So this gives you an idea of how we've done integration with the load balancer. You notice I don't have any, well, I do, but I'm not using it right there. In this particular case, I'm just using a normal REST template that Spring Cloud has created for me. But instead of using a fully qualified URL, instead of a host and port, I have the service name, which if I show you the configuration, Dave showed you this last night in the demo, right? This is the name that gets registered with Service Discovery, with Eureka, just called ribbon demo. Okay? So and I just make a simple call to /me. And actually /me is using our discovery client abstraction to get myself. It knows about itself and how it was registered. And the point is when you see, here, let me start a few of them on different ports. So I've got, these are all just running locally. I have
You've got Eureka running as well.
Eureka is already running here in the background, right here. So I have these 3 different services running now.
Are they running on random ports? How did you set them?
I just set them up with static ports,
right.
Different ones run it at runtime. So you can see here is the Eureka dashboard just on my local laptop, and you can see I have 3 ribbon demos running on 3 different ports. Okay? So now if I hit that endpoint on the first one, 9091, you'll see that it's cycling through the 3 different services just in random order. Now that's just kind of the standard use case. That was bullet point 0. Eventually, it would hit the one that I'm interested. Had we registered it with the tunnel, for example, the one that I'm interested in. Well, I thought, well, what can I do to actually make this interesting? So let's go back to the code here. So I told you about the filters. So I created a filter simply by extending one of Netflix classes. I use Spring Boot's configuration properties. I have this class called demo properties, simple demo namespace, and a filter pattern. This is based on Spring's, pattern matching utilities. They take ant-like
style
patterns, yeah. And again, data there from we'll get a plugin for Lombok. So this filter says given this list of servers, right, this is a method I've overridden, if my property has a pattern, I'm going to go ahead and iterate through each server and apply that pattern to the server ID, and if it matches, I'm going to return it, okay? So how does that work? So I'm going to take advantage of the Spring Cloud being able to poke the Spring environment.
Wait, so you've installed that server list somewhere already?
Yes, this is, yes.
It's already installed.
Yes,
So why
thank
don't we
you.
look at that?
Yes, so.
This is in the application itself.
Right here, so.
Right.
There, like I showed before, here's my ribbon client, and I've installed, if we go look at this ribbon demo configuration, here is my demo server list filter. And an interesting note here that was on the slide that I showed before, I specifically had to remove the @ configuration from here.
Because it was component scanning.
Yes.
But you just put it in a different package. And
I know.
All right. Component scanning, my friends, it's evil.
It's dangerous.
It's dangerous.
And so
Why did we invent that?
I spent a good half an hour trying to figure out why the beans that this particular one, this
We're in the
client
wrong
config
place.
bean, wasn't available when it started up, and I realized that I could have moved the package or just turned off component scanning, but I was lazy and just commented this out. So I've installed it. This serverless filter is in each one of those demo apps that I was already started up. So now, let me make this side a little bigger. We can get it.
If anybody's having trouble seeing that, just shout and we can obviously adjust. Nobody shouted. They're all asleep.
So,
Too much?
So I'm using let's get it all, let's see. So I'm using a little tool called HTTP. I find it a little, HTTPy is its name, little more friendly tool than curl. But the gist is, I am going to make a post to 9091/env, and I'm going to poke this property, the demo filter pattern. And I'm just going to pass this little.
So that's the host name and port.
Yeah, I'm just matching anything that ends in 2, and we'll see what happens here. And you can see the response says this property was changed. So now if I come back to my little client here that was filtering through all 3, is now stuck
on 92.
to 2. So we just said, if we went back to that, ooh,
Nice.
to this picture, I just said, green clients, go to the red service, with matching that pattern. And that's interesting, but that affects everybody, right? Because the way Ribbon works and the way that serverless filter works, that gets cached. And so it's running in a background thread. So you don't have access to any of the user properties that you would like. So this affects the whole service. And everyone will get that. So now
Which might be okay. I mean,
Yeah.
It depends really how you've set your integration environment up, right? I mean, I think there are 2 schools of thought there, right? You either have a developer has his own integration environment, which is ideal, but not everybody has the resources.
Yeah, if you had your own, this would work.
Then it wouldn't matter
perfectly.
anyway. Or you're sharing it with some other people. I think that's what Spencer meant when he said it affects other people. So other people might be developing their own service and they don't want to see all of their traffic going
disappears,
somewhere
right?
else. Yeah.
So I'm going to go ahead and reset that pattern to empty and show a different one. So my friend Rob, what's Rob's last name?
Which Rob?
Spring Session.
Oh, Rob Winch.
Winch, yes,
Yeah.
Thank you. Sorry, Rob.
Too many Robs in the world.
Yeah, he's done some great things with Spring Session, and so I wanted to get that in here as well. So the place where you can have access to user data to basically the request thread is in the actual load balancer. So I created my own instance of load balancer here.
So that iLoad balancer, that's a ribbon thing, right?
Yep, this is the ribbon
It's a
abstraction.
thing. So we're just saying any bean of that type in this context is going to get used.
Yes. And if we take a look at my load balancer, so rather than going to an environment properties, I'm going to actually do 2 things. I'm only going to show one in the interest of time, but I'm going to use Spring Session, which is a nice abstraction over an HTTP session. It allows you to put data into some other data store to distribute your session. In this case, I'm going to use Redis. And I'm going to say if this attribute has a pattern in it, similar to what I did with the property, except now I'm just getting it from somewhere else, right, in a different context. And so
So now you're doing it, if you're doing it per session, then you're basically saying that each user can have their own pattern, right?
Bingo. So if I So I created a client, again, hosted in my same application, but one of the things that Rob had just implemented was being able to find a session by a user ID. So you could potentially have some user interface or API that says, hey, give me the session for user X that is logged into your system, and for me, and then we can find it. So this time so that's basically all this little API here is to set that attribute for my session. I've already logged in. So I'm going to set it to 3 instead, and so now we come back here, and instead of going to 2, it's going to 3, but so if we want to prove a point, right, we'll come, excuse me, I'm going to copy this, come to a new browser that has no session, right?
Log in as a different user.
Yeah, log in again. Basically the same user with a different session. So I'm just going off of session ID, not necessarily user ID, but that, like I said, that could happen with the new APIs that Rob has created. Mm-hmm. So now you can see that in this session, I am going through all the 3, going through the normal cycle, and back here in my session, I only get the 1, right? So this could be how we could route back to just me in a totally shared environment where different users have.
Why didn't it have that static pattern that you set earlier? Oh, did you reload?
I cleared it.
Oh,
I cleared it, yeah. Yep, so there's some fun with Ribbon. I really enjoyed doing this because for a year, I've been saying, you can do this kind of stuff with Ribbon. It's super flexible, and it was fun to actually
I think, so the where we're heading with that, to be clear, is we'll probably make some off-the-shelf server lists and filters that you can just use, and probably ones that the tooling knows about, in fact, so we can probably help the tooling guys to guide the developer experience here, so that in the Spring Boot dashboard, you'll be able to run your app locally, register it with a remote server, and also register a new pattern for the Ribbon.
Right, and just for completeness, I wasn't running the random or round robin rule, it was running a weighted response time rule, right? So this is how you could plug in a different load balancing algorithm into Ribbon. Because that's a pretty common question, how do you change that? So
is that a standard one that comes
yes,
from
this
Netflix?
is this weighted response time is
com.netflix.
Com.netflix, yep. So, Ribbon. Where were we? About here.
Okay, so that brings us to a new topic, really.
Any questions before we move on?
Yes, one. Bill.
Do those rules apply to all of the service endpoints? Because Ribbon might be actually load balancing multiple services, so that filter
Yeah.
could erroneously.
So the question is, does the rule that we just set up apply to all services that we're contacting, or just the one?
And the answer is it depends. So in that particular case, that rule was specific to my Ribbon demo client, Ribbon client. But if you can set a default configuration for every Ribbon client, and then that one could be used. So you can set up a default rule for all your clients, but it's from a client perspective, right? Not from.
Yeah. When you say, it's confusing for me actually. When you say Ribbon client, you really mean the service that you want to contact, right? So there's a global default that applies to all downstream services, and then for each one you can do what Spencer just did as well, and override it.
Right. But it's from a client perspective, right? Yeah. You don't configure the algorithm on the instances. You configure it on the client that wants to contact those instances. Does that make sense?
Yeah.
Because Ribbon is a client-side load balancer, right? That's where it lives. It doesn't live in front of the instances. It lives on the client who is trying to contact those instances.
So another question: when you're using like that secure Eureka that you're talking about, you said it's kind of painful. You have to do some tricks to talk to them. Is it possible using the environment that you're setting that you can just, based on a header or something in your setting, like we were doing, just bypass Eureka altogether, say, when I see this thing, just talk to wherever my laptop is.
Okay, right. So the question is, It doesn't. It's not actually not relevant to whether Eureka is secure or not. But could you just bypass Eureka completely and go to a fixed server if you wanted to? Well, yeah, right, because it's just a server list.
Yeah, I could.
Server list is a server list. You get part of it from Eureka. You get part of it from a fixed list.
Instead of a pattern matching servers I got from Eureka, it could have just been a server, right? And if that attribute was there, just go to whatever the attribute value is, right? Certainly.
It's just a server list. It doesn't have to come from a service registry. I think is really the answer to the question.
My last question is around the tooling you were showing us with SDS. I see you're using IntelliJ, but I imagine that tooling isn't there. So
it's not yet.
Doing that process.
So the question is, what about the IDE? What's available in different IDEs for that? So SDS has got some way towards that. Like I'm saying, we're guiding the tools team towards a picture like this. What they have in SDS is that basic green, red, with a yellow proxy in the middle. IntelliJ haven't started work on that yet, but I know what they're like, right? As soon as they see what's in SDS, they'll probably have it out within a few days. So they haven't done that yet, that I know of. So the next topic, so it's changing gears a bit, really, isn't it? So I mean, I actually like the kind of approaches that we've just been talking about, where I get to develop stuff locally, but it actually interacts in an integration setting with a more or less a live real system. I like that way of working. Some people like to do things in a bit differently, and so they also like to think about the G word, right? Governance. And that's when you start to think about contracts, right?
And consumer-driven, what's the term? Oh, I can never remember.
Consumer-driven contracts.
Yes,
I think it's probably the word you're looking for.
Yep.
So the idea with that is that fundamentally you can avoid a lot of that. The mess that we were just talking about, which is a mess, I'll admit. But the nice thing is that it ends up with me interacting with a real system locally. You can avoid that to a large extent, and people do, right? Our friends at For Finance are really big on this, and we'll show you their tool set in a minute. That Spencer's got a nice demo. The alternative is to think about what it means for a producer and a consumer of, let's just call them messages for now. It doesn't even have to be HTTP. It could be any kind of exchange. But typically, we're talking about HTTP for the examples we're going to show here. What does it mean to have a contract between those two things? And what can you change without breaking your consumers? That's really what it comes down to, isn't it? And that's why it's the G for governance. So there are, at a high level, there are some fairly different approaches to this as well. So maybe, I don't know, these are your slides, so maybe you could talk about those a bit.
Well, so for example, in the, it was just kind of glossed over a little bit, but in the they talked about it in the keynote last night, right? That the UI had been developed with a stub, right, with the service, and I believe you used Spring MVC
to generate stubs.
And basically, you created a Spring MVC app, but all it did was return the contents of a JSON file as a string, as a simple stub, right? So it's an actual running service. It's real Java code, but it doesn't really. It just returns a static list of data, right? That's a simple way. That's one particular way to do a stub, and that's one of those when the service that you want to contact doesn't exist yet in a greenfield situation like they had.
Or doesn't exist in the form that you want it to, which is a situation I come across quite a lot, right? I mean, you've got a legacy system, you want to interact with it, so you want to define a contract with it, but you don't actually have the endpoints in place yet, so you build a stub, so just so you can get some velocity going, right? And that was the scenario we had for the keynote, which is actually in practice quite common. I find that people develop quite large sections of systems without actually having live data in the back of them, and that works.
Yeah, and another situation you come up with is you have all your services, and in one case we'll show you they have actually published stubs somewhere that you can use to verify the interaction with those other services without actually having to stand up all those services like Dave was describing.
Yeah.
So you basically have a stubbed system around your client that you interact with the stubs on the other side.
So instead of having a live integration system, you just there is a system. It's a party that you want to join, but you can join it in a sort of mocked way,
Yep.
not in a real way.
Yeah,
And
so higher level than using, Mockito or EasyMock or something like that. You're still, going over the wire,
Yep.
but lower level than having a full system up and running.
And we've seen a number of different tools and approaches used to this as well. So I was actually just talking to a client last week where we were arguing the debate about this first bullet point. So which should you do? And I don't think there's a right answer, so I'll just explain both approaches. One of them is for your producers, right, to publish their contract and say, right, I'm service A, this is what I look like, and publish that as some sort of stubbable thing that other people can use. And that's the approach that Spencer's going to demo in a minute, I think. The other way of looking at it is kind of upside down completely. And actually, I don't like this, but I've seen people doing it. This is why we were talking about it last week, where the consumers of my service publish their integration tests against my service, and I have to run them. That's why I don't like it, because it puts the onus on me. Right? I think that's too much friction, but that's sort of a higher level of governance, if you like. That's a stronger guarantee that when I publish my service, it's definitely going to work, because if they didn't write their tests the right way, that's their fault. But they're only telling me what they're going to do by publishing their tests. So that's a different way of doing it.
Yep, and we'll look at actually a couple of different ways. I kind of tweaked the way that the 4Finance guys generate their producer stubs using AccuRest and WireMock. And then I think you added the embedded
Stubby
stubs.
4J is another one that I've come across that's it's a bit like WireMock, basically. I mean, it's a YAML, declarative YAML thing. You just declare what the stubs should look like, and they can get the data from different files, and I think there's some sort of basic state machine features in there as well. And I'd also like just to mention, like Spencer was saying in the keynote last night, we were using Spring MVC, and that's actually a perfectly good way to produce simple stubs. Actually, it's just as good as the simple uses of those other things. It's just that the thing that you can't do very easily with any of this actually is real stateful stuff. So if you're sending a message to a service and you expect it to change its state as a result, and then you want to test that state with another call, that's going to be challenging for a stub. So that's actually where it often falls down, I think. But
Yep.
Anyway, so we're going to show you a bunch of these things. There's also the whole thing about whether the stubs are running in the same process as your tests, or whether you run them remotely as individual services, or maybe as a single service that mocks everything.
Yep. And the tools from 4Finance allow either. I'm going to show embedded stubs. In fact, so that's kind of the general pattern that I'm going to use for doing these brownfield stubs uses WireMock, and I'm going to show two different ways to generate the JSON file for WireMock using. They showed Spring REST docs yesterday, so I'm actually going to show how to use REST docs to generate the stub. So along with your test comes the stub, or AccuRest has a Groovy DSL that they use. The 4Finance guys are pretty heavily involved in AccuRest. I don't know if they run it, but
I think Martin actually
does. Is that his project?
Yeah,
okay.
I think it's his project. Yeah.
So they like this, and it's a Groovy DSL, and I'll show you a little bit of that. But once those stubs are generated, WireMock loads those stubs up and runs a service. The stub runner I actually have registers. So here we're going to actually transition from Eureka as a service registry and discovery to Zookeeper. So you'll get a little bit of that. Did you guys show that?
No, we didn't
today?
have time.
Okay.
No, we said that you would do it.
Awesome. Again, you'll get more Thursday on Zookeeper, but it's the stubs actually get registered in Zookeeper, and the client, when it behaves normally, it just says, "Hey Zookeeper, give me a service X," and Zookeeper returns the host and port of the stub, and then it makes its normal call. So it's a pretty slick little integration where the stubs actually are registered with service discovery.
You could do it with Eureka just the
Yep,
same
you
way,
could, you
which
could.
still would work.
But the Zookeeper, so For Finance has donated a lot of our Zookeeper code, and so they have some of the stuff already built for Zookeeper. Generalized a little bit, and it could be made available.
I think it is, yeah.
Yeah, more available to
We've got
the other
20 minutes.
services.
You've probably got time to do this demo quickly
Yep.
before we get to the end. Let's just look at the sides first of all the different.
Sure. So this is a sample of the Accurus DSL. I don't know that we need to get into it too much, but so this says at URL foo with the HTTP method get, this is what the response should look like. I'm just going to return this simple value.
So that's Groovy. Yeah, I've seen YAML.
Yep. Whatever.
Yeah.
So Spring REST docs, right, that they showed yesterday is just the generic way, except I created a new snippet here that says,
A snippet is a REST docs thing, right?
Yes.
So normally what they do is when you run your tests, it generates example requests and responses,
Right
which
here.
you include in the documentation as
Yep.
snippets. And there's a certain format that the snippet has to have, right? So it's just plain text, or it's got, in this case, some wrap around it.
yeah, so I created for this demo something called the WireMock stub snippet that could eventually make it out to something more generally available. And then instead of using the DSL, you describe what this should look like. So /foo is a JSON, should return OK, and we're going to go ahead and document foo.
There's one more, isn't there? Two more.
Yeah, and this is what ends up getting generated using either of those methods, just to show you this is the format WireMock expects. Of course, you could have just written this, right? Is one way to do it. Just write the WireMock stub in the JSON, right?
Everybody likes to edit JSON, right?
Yeah, I personally have, when I did this, I really wanted to get the REST docs working because I generally like this.
Yeah, I like
because
that.
as your application changes,
The stub's
it's going to
changed.
break your test, and you'd have to go in and fix it. The stub gets updated. Things happen in a more automated fashion. So this would be something that for Spring MVC, right? So /locations. In fact, this is
what we were using last
This
night.
is
yeah.
exactly
I
what
didn't
you're
show
using.
the code, but it's
Yeah.
just a simple Spring MVC forward to a static resource.
Yep.
Very simple. You can do gets and posts. It's a little bit of a more challenge to do anything. Yeah, some of the more complicated interactions, like anything stateful, but it works pretty well
Yep.
for simple cases. Okay, so you can probably do your, okay, so this is what it's about, right?
Yes.
Stub
So this stub runner from For Finance, what happens is during your build, the WireMock stub gets generated. It gets packaged into a zip file or jar file, I don't remember, and then published to Nexus. So For Finance uses this internally. They publish all their stubs so that every consumer of all these applications just knows where to get their stubs. So the stub runner comes up, and there is I will show you the list of dependencies, each service. So in general, the way we have done service clients, you don't have to know up front what I'm a consumer of, right? You just at runtime, you say, I need to contact, the red service. But for this to work, you have to list your dependencies in the application.properties or YAML file that says, I'm a consumer of red, so that StubRunner knows which dependencies to go get from Nexus. And then, like I said, it will spin up a WireMock server for each dependency and then register those servers in service discovery. So let's go see it happen. And this was actually good. If we would have used Dave laptops, we wouldn't have been able to do this demo. So one demo was going to not work today, and
We
it was
sacrificed that one.
his, yeah. So I have, just at a real high level, this simple application. There's two providers, a food provider and a bar provider. Yeah, I know I can't actually on that side. So I'm just going to tell you, there's 2 providers and 1 consumer. Let me show you the application.yaml. So this is the foo consumer configuration. Oh, sorry. And so here's this list of dependencies. So foo consumer depends on foo provider and bar provider. Okay, that's the topology. Consumer with 2 providers. And some configuration for stub runner. So if I run this guy, he's actually already running.
So he's going to actually run something in process,
So
which will stub both of those foo and bar providers, right?
yeah, so what actually is happening when this starts up, because Zookeeper is Java-based, it's actually starting the service discovery provider. It's starting each stub and then starting the actual consumer application. So I actually wrote let's see, what port am I on here? 8081, okay. So I actually thought this would be, I wrote an actuator endpoint for the stub runner that says, hey, what stubs have you started? So we can see that foo provider is on localhost 14 blah, 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 and bar provider is on some other random port, right? So this gives me a little visibility into the stubs. And so now I can hit my local consumer, and these values came from the stub from foos. Yep.
Via a REST template call.
Yes. Yeah. And again with the other dependency, the consumer application. If we want to take a look at it, I have a separate consumer service here. But when I called foos, it simply went to foo provider / foos, and so it was a real REST template call just to the stubs. Okay? So this application was running in total isolation, including the service provider and the stubs running dynamically. So this is something if the 4Finance guys here were, they would they love working with this style of stubs.
10 slides, let's just flip through a few. Okay, yeah, and then so we got, in the last 10 minutes, we've got a whole other set of topics basically about topics around, if you make a change locally, how quickly can you get it deployed and in action? So the sort of broad subtopic is hot reloading and code swapping. And there are a number of different ways of doing this, right? So there are already, in most IDEs, although IntelliJ users seem to find this very difficult, JVM hot swap has been a feature since like Java 1.6, I think, or maybe it was 1.7, 1.6, I think, which means if you make a class change and it didn't change the signature of a method, then the JVM can just replace it, and the IDEs will happily do that for you so you can continue to work. I use that feature all the time. It also means that you can, generally speaking, reload static resources like HTML, style sheets, stuff like that. That's the bit that the IntelliJ users have trouble with for some reason. Eclipse just seems to do it. Then, okay, the next level up. So I think Phil might be talking about DevTools in more detail, but I very briefly mentioned it last night. I'm not sure we're going to have time to look at it in any detail. Spring Boot 1.3 shipped with a new library called DevTools. So if you include that on your class path, it basically gives you a couple of new features. One of which is it monitors the class path, and if you make a change to a class, now you can do anything, right? So now you can create a new class, or you could create a new method, or you could change a method signature, and do anything. Then it will, the IDE, generally speaking, is just going to recompile that. And the challenge then is to get it into a live deployment. And so what the DevTools do is they use a class loader trick to basically throw away the old class, load the new one, and then actually restart the whole Spring application context. And that might sound like a drastic thing to do. It is a bit, but it turns out that it's a lot faster than you think it might be, because, for instance, if I'm running Hibernate, Hibernate doesn't have to get reloaded. It's only the application classes. So Hibernate can just stay warm, and it doesn't take so long to reload the Spring application context, because that itself isn't very resource intensive. The other thing it comes with is this thing called live reload, which is a thing on the internet. Just Google it. For that, you get a browser plugin, which isn't anything to do with us, but you install that in your browser, and what it does is it reloads the browser. So if you're visiting a website which you're developing locally, it's basically detecting changes. The IDE is detecting the changes, but then it's broadcasting those to your browser plugin, and so there's a protocol for that, which is called live reload, and that works really well. SDS supports all this stuff kind of quite natively now, so especially the live reload, it's a little bit fiddly to set up. You've got to run a separate sidecar process. It tells you how to do that in the Spring Boot documentation, but SDS just does it, right? So you can, if you have dev tools on your class path, SDS detects that and just does everything for you. The next level is Spring Loaded, which is a Java agent that we built but don't use that much. Grails uses it, JHipster uses it. We showed what they were doing to Jürgen, and he kind of flipped his lid. So, so we haven't pushed it all that hard. It's a Java agent technology, and it works for a limited class of Spring reloading problems, basically. And then you've got the professional standard, which is JRebel. If you can afford to buy it, it's definitely worth it, because it does save a lot of time if you're doing a lot of different things. It knows about Spring, and it knows how to reload stuff without starting the application context again, basically. Okay, so we've just got some diagrams that show how some of those things work. The hot reloading locally, so just making a change, and then restarting the application context. That's the DevTools. Next one is DevTools with the browser plugin. So the browser plugin is now listening to a sidecar. The sidecar pushes the change, and the browser reloads through a plugin. And then the last thing, which is really cool, which I really did want to demo. A, we don't have time. B, my laptop's not connected, but I'll demo it to anybody. Actually, later on, probably tomorrow would be better, because I've got another 2 presentations now today. I need to go and get ready for them. But SDS, in particular, lets you do this with also remote debugging. So this client app, the sidecar that facilitates the live reload, also can act as a tunnel for a remote debugger. And so you can have a process running in Cloud Foundry, you set a breakpoint in it in your local code, you hit the service remotely, and it actually breaks. It's very slow, this remote debugging, so it's the last resort, but it actually is easy to set up with SDS. Next one. Right, so actually that was that topic finished, and then we just wanted to have a few words at the end about how do you, as a developer, how do you sort of interact with the application lifecycle? That's what the AL is, and the ALM management. And some cloud native messages for that, basically. So this ad hoc deployment and mixed local remote that I've been talking about, I like it as a development time thing, but it's also always going to be better to hook into some kind of automated pipeline as you go further downstream towards the production system. So just a few words of warning. Always automate it downstream of there. Always make it part of a CI process, I would say. The next one's burnt me before. Stay as close as you can to the production platform. Don't try and figure around with integration tests and everything that you think are like the production system and not. It's not worth it, because, especially with Cloud Foundry, for instance, it's so cheap to create a new environment. Why would you do anything else? And, fundamentally, don't redeploy everything for every change, because you'll get to the point where it's just not possible. I think we're going to have to, yeah, okay. So how would you debug a request? I was going to do a couple of demos with the trace endpoint.
I can show the trace endpoint I've got.
Yeah, might as well just show that quickly. There you go.
So these are, that's not a very good one, but here's my last request to slash, and it gives requests, headers, response headers, statuses, etc.
Yeah, I find that quite useful with the Zool proxy as well. So if you're doing a gateway, API gateway pattern, you can see the first request, and then you can see the proxy request as well, which is quite useful. Okay, finally, next one. How do you get the middleware ready? If you're going to test something locally, it's a pain to have to, reset the state every time you want to run a suite of tests. So the thing that I always use these days is Docker.
Docker Compose
is absolutely perfect, yeah, because you can just blow away the state and start from scratch. Okay, fine. Okay, so how do you discover and do DI on middleware? So that's another thing about 12-factor, right? Make it the same everywhere you go. And one way to do that is to use Spring Cloud connectors a bit. I'm actually not a big fan of using them for everything, but I can talk about the detail more if anybody's interested. And then I think that is finally the end, isn't it? The last slide is about, different ways of provisioning. So everybody's got a favorite. Docker Compose, I think, is great for middleware. It's great because you can just blow everything away. A lot of people use these other things, VirtualBox.
That's one.
Yeah.
My colleagues here still have my old VirtualBox configuration running. So.
With Vagrant, you can do both VirtualBox locally and kind of lots of different remote systems now as well, can't you? So Vagrant's a really nice tool.
And
actually,
Compose actually can start to do that with
that's
AWS
right,
as well.
Yeah,
so.
AWS now has these Docker machines, doesn't it? Okay, so there's different approaches to that, and then finally, I think just got some links at the end because we do have to finish. So if anybody wants to follow up on this, come and ask us. I'm going to disappear because I've got to go and present, get ready for another presentation. Spencer will be here. We're all here the whole week, so come and stop us and talk about any of these things. A lot of it, you can tell, is work in progress. We're thinking about it hard. We're developing hard, and we're going to start pushing the tools in this direction, starting from now, basically. So if you have opinions, if you've got some battle stories, we'd definitely like to hear those as well. So thanks very much.
Yes,
and
thank you very much.
Hope to see you
Great
later
to
on.
see you.